In this module, we analyzed 2 seconds of EEG data. We started with visual inspection of the EEG time series. This is always the best place to start when analyzing new data and provides some important initial intuition for the time series. Through our initial visual inspection, we concluded that rhythmic activity appeared and was dominated by a 60 Hz oscillation. Then, to characterize further the rhythmic activity, we computed the spectrum. To do so, we first introduced the notion of the Fourier transform and discussed in detail how to compute the spectrum in MATLAB. We also defined two fundamental quantities, the frequency resolution and the Nyquist frequency, and explored how to manipulate these quantities. We recommend you continue to think about both quantities and commit both to memory. For every time series you encounter, ask yourself, what is the frequency resolution and what is the Nyquist frequency? We then considered how a logarithmic vertical axis can be used to emphasize features of the spectrum, and finally how the spectrogram provides insight into spectral features that change in time. We concluded that the EEG data are dominated by 60 Hz activity throughout the 2-second interval, and that weaker, low-frequency activity emerges during two intervals, a 6 Hz rhythm for the first second and an 11 Hz rhythm for the last second. This module provides only the briefest introduction to spectral analysis. There are many details and issues for further exploration and consideration. If you're interested in more details, please check out the references provided in this module.